Welcome back to Zero at Math. Today we're tackling one of the most elegant, infinite, nested radical expressions you will ever see. The square root of 8 plus the square root of 8 plus the square root of 8, continuing forever. In math notation, that is the square root of 8 plus the square root of 8 plus the square root of 8, and so on without end. This kind of infinite nest looks intimidating at first, but the solution is surprisingly clean and exact. Let's dive deep into how we solve it step by step, explore why it works, look at some approximations to build intuition, and even talk about the history and generalizations of these beautiful objects. First things first, because the nesting goes on forever, and every layer is identical, the entire infinite expression must equal some fixed value. Let's call that value x. Notice that inside the first square root, after the 8, we have the exact same infinite expression again. That means the thing inside is also x. Therefore, we can write the self-consistent equation x equals the square root of 8 plus x. That is the key insight. To solve this, we remove the square root by squaring both sides. Squaring gives us x squared equals 8 plus x. Now bring all terms to one side to get a standard quadratic x squared minus x minus 8 equals 0. We could try to factor, but there is no nice integer factorization here, so we use the quadratic formula. For a times x squared plus bx plus c equals 0, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a, here a equals 1, b equals negative 1, and c equals negative 8. Substituting gives x equals 1 plus or minus the square root of 33, all over 2. The two values are approximately 3.372 and negative 2.372. Which one is valid for our original infinite radical? Remember, the square root function returns a non-negative value, so the entire expression must be positive. We discard the negative root and keep the positive 1 only, so the exact value is 1 plus the square root of 33, all over 2. To build intuition, let's verify it numerically by nesting step by step. Starting with a seed of 0, we compute levels. Level 1 is the square root of 8, which is about 2.828. Level 2 is the square root of 8 plus the previous value, which is about 3.291. Level 3 is about 3.360. Level 4 is about 3.370. Level 5 is about 3.372. Level 6 is still about 3.372. It stabilizes quickly at the exact value. Here is a geometric view. We plot y equals x, and y equals the square root of 8 plus x. The intersection in the first quadrant is our solution. The point lands at x about 3.372, matching the exact value, 1 plus the square root of 33 over 2. A quick historical note, the classic nested radical is the square root of 6 plus the square root of 6 plus dots. Setting x equals the square root of 6 plus x gives x squared equals 6 plus x. Then x squared minus x minus 6 equals 0, which factors to x minus 3 times x plus 2 equals 0. So x equals 3. In general, expressions of the form the square root of k plus the square root of k plus dots satisfy x equals the square root of k plus x. Squaring gives x squared minus x minus k equals 0. So the discriminant 1 plus 4k must be non-negative, meaning k is greater than or equal to negative 1/4. When it converges, the value is 1 plus the square root of 1 plus 4k, all over 2. 4k equals 8. 1 plus 4 times 8 is 33, which is exactly what we used. So there you have it, the infinite nested radical. The square root of 8 plus the square root of 8 plus the square root of 8, and so on, equals exactly 1 plus the square root of 33 over 2. If you enjoyed this elegant algebraic gem, hit like, share your favorite nested radical in the comments, and subscribe to Zero at Math for more mind-bending problems. Thanks for watching, and see you in the next one.